Hello friends, my name is Akshans and welcome to CAD Academy. In previous lecture we have studied the first order differential equation, and in this lecture we will cover the higher order differential equation. So there are few things which we will have to know before solving the higher order differential equations. Okay, so in higher order differential equation we calculate both CF and PI. This is what complementary factor, and this is what particular integral. Okay, this is particular integral and this is complementary factor. Okay, and by adding both complementary factor and the particular integral, we get the general solution of that higher order differential equation. Okay, so we have few cases. Okay, case 1 is what? So while calculating the complementary factor, when both roots are real and different. Okay, when both roots are real and different, then we have complementary factor as C1, where C1 is a constant, and e to the power that root alpha 1 into x, okay, plus C2 e to the power alpha 2 x. Okay, alpha 2 is second root and this is what? First root of the equation. And if we have three different roots, if we have third order differential equation, then C3 e to the power alpha 3 x and so on. Okay, so this was for the equation which has different roots. Okay, here now we will see what if the equation doesn't have different roots. Okay, so if we have two same roots, okay, same or equal roots, okay, so then what we do, the complementary factor is what? C1 plus C2 x into e to the power alpha 1 x. This alpha 1 is same as alpha 1, alpha 2, or say alpha, because we have same roots. Okay, what if we have three same roots? Then CF will be what? C1 plus C2x plus C3 x square into e to the power that alpha into x. Okay, now what if we have imaginary roots, or say complex or imaginary roots? So at that time, for two roots are imaginary and different. Okay, and let's say that roots are alpha plus minus j beta. Okay, then the complementary factor will be what? E to the power alpha x C1 cos beta x plus C2 sin beta x. Okay, so this is what? Case 3. Okay, and at the same time when we have two pairs of complex roots which are what, alpha plus minus j beta, and same thing again, alpha plus minus j beta. Okay, so when we have two equal pair of imaginary roots, then we have complementary factor as what, e to the power alpha x c1 plus c2x into what, cos beta x plus c3 plus c4x into sine beta x. Okay, so these are the things. Please take a screenshot of this, because whole higher order differential equation is completely dependent on these four cases. Okay, this is what, case 4. Okay, so let's start understanding these four cases by solving the problems. Okay, so this is what, how we calculate the complementary factor of a higher order differential equation. So for the PI, I will tell you that later while solving the problem. Calculation of PI or the formula of PI is very simple. You just have to remember the procedure only. Okay, no formula for calculating the particular integral. Okay, so now I am taking a problem which is what, we have to get the general solution of the equation which is what, y double dash plus 4y dash plus 5y is equal to 0. So this is the problem for which we have to get the general solution. So simply, so this thing is what, is equal to 0, so we can say it is a homogeneous differential equation. So for the homogeneous differential equation, the general solution is just complementary factor. We don't have to get the particular integral for this particular equation. Okay, so writing the solution for this, so this double dash, we write it as d square plus 4 into single derivative, we will write it as just d, and no derivative, just a constant, is equal to 0. So this equation we call it as auxiliary equation. Okay, so d means derivative here. Okay, so we will get the roots of this equation, and the roots are minus b plus minus b square minus 4ac by 2a. Okay, this is b, this is a, 1 here, 1 is a, this is b, and this is what, c. So by using this formula you will get a root, you will get the roots of the equation, which will be what, this thing, minus 2 plus minus I. So here we have a pair of complex root. So we have seen just before 5 seconds that general solution for the pair of a complex root, we have what, complementary factor as e to the power minus 2x c1 cos x plus c2 sin x. Okay, c2 sin x. So this is what, minus 2 is what, alpha, and beta is what, just 1. Okay, so the coefficient of I or j, which is what, 1 here, so beta is equal to 1. So by using the case 4, we got the solution as y is equal to this thing. Okay, So this is the solution for this differential equation. Now taking another problem, which is what, y triple dash minus 6y double dash plus 11y dash minus 6y is equal to 0. Again, this is a homogeneous differential equation, so the general solution for this equation will be just the complementary factor again. Okay, so simply as we done before, this is d cube minus 6d square plus 11d minus 6 is equal to 0. This is what? Auxiliary equation. Okay, so by just seeing this, we can say that d is equal to 1. At d is equal to 1, this equation becomes 0. Okay, at d is equal to 1, this will be 1 minus 6 plus 11 minus 6, which is equal to what? 0. So this is the one root of the auxiliary equation. We got one root of this third order auxiliary equation. So for rest of the root, what we will do is we will write here d is equal to 1, and here we will write this 1 minus 6 11 and here minus 6 again. So what we will do here now, that is what, we will write this one as it is here. Okay, now we will add these both numbers. Okay, after writing this, we have to multiply these both things, and then we have to add these both number. We will have what? Minus 5. Now again we have to add these both number, and we have what here, guys? 6. Now again we have to add these both numbers. We have what? 0. So this is again the coefficient of second order differential equation, or say this is again the coefficient of second order equation. So we will write it as d square minus 5d plus 6 is equal to 0. Okay, so we can get the roots of this equation. We have what? Minus 3 and minus 2, which is the number whose sum is minus 5 and multiplication is 6. So just change the sign. 3 and 2 are the roots of this equation. Okay, so we got the three roots of this auxiliary equation, and which is what? 1, 2 and 3. Okay, so we know the complementary factor when we have three different roots. So c1 e to the power x plus c2 e to the power 2x plus c3 e to the power 3x. Okay, 1 2 3. So 1 2 3 here, and these three are constants. So this is how we can solve all the 4 cases problems. Now I am taking a non-homogeneous differential equation. Okay, so that is what? Y double dash minus 4y dash plus 13y is equal to e to the power 2x. Okay, so here we don't have 0, so we can say this is a non-homogeneous differential equation. Okay, so now we will find the general solution for this equation, and for this equation we have general solution as complementary factor plus particular integral. So as this equation is non-homogeneous, so there will be particular integral, and the complete general solution will be complementary factor plus particular integral. Okay, so we know how to calculate the complementary factor. To get the complementary factor, we have to get the roots of the equation. We have to form auxiliary differential equation, or say auxiliary equation, for getting the roots of the equation. Okay, so this is how d square minus 4d plus 13, which is equal to 0. So we will get the roots of this equation, and we can get the roots of this equation, roots of equation by minus b plus minus b square minus 4ac by 2a. So by using this formula you can get the root of the equation, and which is what, 2 plus minus I into 3. So these are the both roots of the equation. So the complementary factor will be what, e to the power 2x, this thing, and cos beta x, which is what, 3x, plus sin beta x, which is what, 3x, and here we will have a constant c1, and here we will have constant c2. So this is the complementary factor for this equation, and now we have to get the particular integral. So for particular integral, what we will do, we will write the reciprocal of this equation, and that is what, d square minus 4d plus 13, and we will multiply this equation with e to the power 2x this term. Okay, so we can observe that complementary factor is not dependent on this term, but particular integral is. So to calculate the particular integral, what we will do, this 2 we will put d is equal to 2. Okay, so putting d is equal to 2 in this equation, what we will have, 2 square minus 4 into 2 plus 13 into e to the power 2x. Okay, and now solving this, we will have 1 by 4 minus 8 plus 13 into e to the power 2x, and which will be what, e to the power 2x by 9. So the complete general solution will be CF plus PI, and which will be what, this e to the power 2x, c1 cos 3x plus c2 sin 3x plus e to the power 2x by 9. So this is the general solution which we will equate to y. So this is the solution, this is the procedure of getting the solution for the equation which has non-homogeneous term as e to the power alpha x. So for that we have to put the alpha is equal to d while calculating a particular integral, and complementary factor, we just know the procedure for this. Okay, so now I am taking another equation, and which will be what, non-homogeneous differential equation, and we will calculate the particular integral for that also. Okay, so next problem I am taking is y triple dash plus y is equal to sine 3x. So for this equation we will calculate only the particular integral, because CF is just has the same procedure, we have to do that thing again and again, so we are not doing that, and we will get the particular integral for this equation. So for particular integral we have to take the reciprocal of the auxiliary equation, which is this. Okay, and multiply the thing with sine 3x, which is what, non-homogeneous term. So what we will do here, So here we will put the d square value as this 3's square and a negative of that, which will be about minus 9. Okay, so we have to put the d square value as minus 9 here. So what will be that? We can write this d cube as d square into d plus 1 into sine 3x, which will be what? 1 by d square is equal to minus 9, so minus 9d plus 1, which is this thing. Okay, now what will we do is we will get this d in the denominator, and for this we will multiply the equation with 1 plus 9d in the numerator and the denominator also. So we will get this thing, and again this d square value we will put minus 9, so that will be what? 1 plus 9d by 1 minus 81 into minus 9 into sine 3x. Now rewriting the same equation again, 1 plus 9d by 1 minus 81 into minus 9 into sine 3x. So this thing will get outside, and that will be what? Like this, and we will have what? 1 plus 9d multiplied with sine 3x. So 1 by 730 and sine 3x into 1, that will be what? Just sine 3x, and sine 3x 9 into differentiation of sine 3x, so that will be what? Cos 3x into 3 here. So this will be what? 1 by 730 into sine 3x plus 27 cos 3x. So this will be the particular integral for that equation. Okay, now I am taking another problem, and we will calculate the pi for that also. And the equation is what? Y double dash minus 4y dash minus 2y is equal to what? X square. So here we have a polynomial at this side, and let's see how to get the particular integral for this equation. So to solve this, pi will be what? Again the reciprocal of that auxiliary equation, this into x square. So what we will do here is we will take the constant out. So minus 2 is the constant here. We will take this out, and which will be what? 1 minus d square minus 4d by 2. Okay, into x square. So if this minus 2 gets multiplied here and in this equation, we will get this equation back. So what we will do here is, we know that 1 minus x inverse is equal to 1 plus x square plus x cube plus so on. So this is the expansion of this thing. So we will rewrite this equation as 1 by 2 and negative of that into 1 minus d square minus 4d by 2 is all things inverse here, and into x square. So this thing is this, and we will make this by using this expansion. So we will have what? Minus half, and 1 plus x is this thing, So d square by 2 minus 4d by 2, this is what, x, plus x square, so that will be what, d square by 2 minus 4d by 2 and square of that, plus we have to go like this and we have x square here. So if we have here second order polynomial, so we don't have to go above the second order, because after that we will have third order derivative and that will be 0 here. So we are neglecting the higher order terms. So after expanding this, we will have what, 1 plus d square by 2 minus 2d plus 8d square, and rest of the things will be of higher order. So this is what we got, and minus 1 by 2 into this x square gets multiplied here, that will be x square only, plus x square into d square, that will be what, double derivative of x square, that will be what, just 2, because first derivation of x square, that will be what, 2x, and second derivation will be what, 2x, second derivation, that will be what, 2 only. Okay, so after that we have 2 into first derivation x square into d, that will be what, 2x, plus 8 into second derivation is what, 2. So this is the thing, and after solving this we will get what, minus half into x square plus this will be what, 1 minus 4x plus 8 2, which is what, 16. So writing the solution generally, we have what, so this is the particular integral for this equation. Now I am taking another problem, which is what, y double dash minus 2y dash plus 5y is equal to e to the power x into cos 3x. So here what we have, exponential term also and sinusoidal term also. How will we solve that? So let's see quickly. So again we will do the same thing, 1 by auxiliary equation, this thing, into e to the power x cos 3x. So what we will do here, we will make d as the d plus alpha, and what is alpha, guys? This thing is alpha, which is 1 here. So d will tends to d plus 1. So now this equation will have e to the power alpha x, where alpha is 1, this will be outside the differential equation solution, and d will tends to d plus 1, which is what, alpha, and square here, minus 2 into d plus 1 plus 5 into cos 3x. Now this problem has been very similar to previous problem, previous problem I think, where we had put it the d square value as the minus 9. Okay, so we will do the same thing here. After that we have what, d square plus 1 plus 2d minus 2d minus 2 plus 5 into cos 3x. So what we will have here, e to the power x, and here we will have what, this thing gets cancelled, and d square, okay, plus 4, okay, d square plus 4, and into cos 3x. So we will put the d square value as minus 9. So e to the power x into 1 by minus 9 plus 4 into cos 3x, and which will be what? Minus e to the power x by 5 into cos 3x. So this is the particular integral for this type of equation. Okay, so by this question we are done with the differential equation. Thank you for watching the lecture, and please share and subscribe the channel.